The title for this presentation is a look inside the human factors called Cognitive Engineering Lab. As I mentioned, Stratus exists like since 2014, and since then we had a lot of research within Stratus. But last 2 years ago, we had the opportunity really to crystallize the research lab, focus on these two aspects, that's human factors and cognitive engineering, how those science can be applied to improve patient safety in several settings. And since then, 2 years ago, the lab has grown a lot, and we have new people, and we're really doing some very interesting research that I'd like to share with you. In terms of the lab team, our team is really huge. It's much bigger than this one. But here I would like just to bring like the people who are like full-time for research in our lab. So myself, I'm Director of Research Innovation for Stratus, and I'm leading the lab. We have Christian Micheli, who is our research assistant, and Christian has a background in biomedical engineering, and he's working with us now for 2 years in the lab. And Christian was like our first research assistant for the lab, and is working with like physiological signals processing analysis. Dr. Madi Ebnali is our postdoc fellow, research fellow. Madi has a background in systems engineering and also in extended reality and human factors. And Madi is involved with almost all of our projects, working on extended reality development, human factors experiments, and UX. We have Dr. Sandra Park, who is our simulation postdoc fellow. Sandra is a general surgery resident doing her 2-year gap between the surgery program, doing her research. She's also doing her master's in health professional education at the MGH IHP. And Sandra is working in a few projects with us, mainly now focused on trauma team training. Fanny Paladugu is our second research assistant. Fanny has worked with us since 2020, work on the NASA project. He has a background in biomedical engineering, and he just completed a master's in bioethics here at the Harvard Medical School. So that's our core team that's like full-time dedicated to the lab. And of course, we have many other Stratus faculty who work with us, and Dr. Deborah Navedo, who is the Director of Education, Dr. Valerie Dobies, who is the Director of Internal Programs, Dr. Andrew Eyre, who is our Medical Director for Stratus, and also within the Department of Emergency Medicine, we have many other faculty who are involved as collaborators in our research here in the lab. Our research is really collaborative. So these are our current collaborations. So university centers who we have co-investigators, PIs, and with whom we have current collaboration. Brigham, other departments, so we are in the Department of Emergency Medicine, but we have collaborators from Department of Surgery, different divisions, general surgery, cardiac surgery, thoracic surgery, urology, the Center for Surgery Public Health at the Department of Surgery, the Ariadne Lab, that's also part of the Brigham, the Department of Anesthesiology. Mass General Hospital, we also have current collaborations, Department of Anesthesiology and the MD PNP Lab at the MGH. The VA Boston Healthcare System, we have 2 grants in collaboration with them, the Department of Cardiothoracic Surgery, led by Dr. Marco Zanetti. University of Michigan, also cardiac surgery, and the Department of Electrical Engineering and Computer Science. The University of Massachusetts, also College of Information Computer Science. The MIT, the Interactive Robotics Group with Dr. Julie Shah, Department of Mechanical Engineering, Georgia Tech, Rice University, NASA, the Ames Research Center. So these are all the institutions, and for each institution, many different co-investigators, which we have a current collaborations. And that's really what makes our work really fun, and we are learning every day, is really having the opportunity to collaborate with this multidisciplinary group. That are not only from medicine, but from engineering, psychology, space, and many other areas. And that, to me, is like what makes the lab more interesting and rich, is really this multidisciplinary aspect in which we can learn a lot from each other and do high quality research in a multidisciplinary team. And I'm going to highlight a few of the projects that we're doing with these institutions. The lab has matured for the past few years, and in the stage that right now we have 6 federal grants is a current funded research. Unfortunately or fortunately, we don't have any more like non-funded research, because we're able to secure funding for all our research efforts. And basically all the work we do nowadays here at the lab is or working for a grant or collecting preliminary data to apply for grants. So we're very fortunate to have right now 6 concurrent federal grants. I'm going to talk about each one of them. So the most recent one is this grant from the NIH, the National Heart, Lung, and Blood Institute. It's a R56. That's basically R1 funded for the first year. And in this grant, it's a collaboration between us, our lab, Dr. Michael Gombley from Georgia Tech, and also the VA hospital, Dr. Zanetti and Dr. Goldman at the MGH, to design, develop, and get a validity evidence on a robot-assisted perfusion system to improve patient safety in the cardiac operating room, basically using machine learning, artificial intelligence, to learn from expert perfusionists and teach the machine to make decisions like expert perfusionists do. And also in a later stage of this research, we will develop a clinical decision support system that can actually watch and observe what's happening in the operating room and provide recommendations to the perfusionist, especially in critical situations, for example, during the bypass phase of cardiac surgery, when one of the examples, like when the patient oxygenation, cerebral oxygenation is low, what means like low perfusion, and what the system can recommend to perfusionists in terms of decision making. That's something we are doing and using our expertise in human factors and cognitive engineering and leverage our collaboration. So this grant just started this month. The second one that also is starting this month is this grant from the Agency for Healthcare Research and Quality, the AHRQ. That's also a federal agency focused on healthcare research and quality and patient safety initiatives. For this grant, I and Dr. Deborah Navedo, we are collaborating as co-investigators in the revision of the TeamSTEPPS. That's a recognized and well and widespread applied framework for teamwork training. And Deb and I are going to work on this grant focus on strategies and tools to enhance performance and patient safety, most specifically designing simulation-based tools and material to enhance the curriculum of the TeamSTEPPS. We also have this grant from the DoD, the Department of Defense. That's our grant in which we are developing a virtual reality platform for emergency care training in austere environments. And for this grant, we're developing some VR scenarios to be used in the military personnel mobile phones, so they can do continued training in emergency medicine, even when they are deployed, because most of the training, like space, you're going to see the space research for the military, the training is or in the US or in the large hospitals or units we have spread around the world. And when the military personnel are deployed in the environment, sometimes for long periods, they need to do some refresher training. And the goal here is that they can use their tablets or their cell phones to do refresher training in emergency care, especially in trauma combat casualties. And we are developing this platform in collaboration with industry, two companies, Radiant Imaging and Panorama. There are the three grants we are currently working. This one is funded by NASA, Mixed Reality Care Delivery Guidance System to support medical event management on long duration exploration missions. Similar to the DoD, we're also developing training scenarios, but here not only for mobile-based virtual reality, but also for headset-based VR, full immersive VR, and also augmented reality, AR. And Maddie is working very close in that project, developing some of the applications. Different from the Department of Defense, here we're developing two things. One is training applications using extended reality, but also developing clinical decision support tools using augmented reality. So basically what we're creating is a system in which we can use augmented reality glasses with real patient care, in this case in space, and have a guidance from the system to go, for example, through a checklist and interact with this checklist via voice command and get some cognitive aid capabilities using augmented reality. So in this project, we are now finalizing the second year, and after that, we're just finalizing development. We are now planning to collect data here at Stratos with participants. The other grant is also NIH, NHLBI, our one with Dr. Zanetti at the VA Hospital Cardiac Surgery, in which we're developing a novel cognitive-based guidance system to improve surgical safety. Again, you see a lot of like common topics across our research apply in totally, completely different settings, right? So we're applying some of these like cognitive guidance systems in the operating room with real cardiac surgery patients, and also in virtual reality for space travel, and also in military environments, right? And that's really what we're trying to do with the lab, is like how to use the same or similar technologies and methods to apply for a common thing that's like enhancing patient safety and improve patient care in different settings. Can be operating room, emergency room, space or military environment. And that's also very exciting, how we can translate what we learn from one field and one environment to other, how we can adapt those methodologies and those products and really apply the human factor science and the cognitive engineering science to help us to better understand clinicians' performance and also to support performance in the clinical environment. The last one is also cardiac surgery with the University of Michigan, the Department of Cardiac Surgery. We are developing novel assessment tools of technical and non-technical skills in cardiac surgery. For this one, we are using computer vision and cameras to develop and validate automated metrics of performance in the operating room, only using motion analysis. Measures of the surgeon technical performance, for example, the psychomotor skills of the cardiac surgeon during real patient care based on pattern movements, motion patterns extracted from real surgeries and correlated with real patient outcomes, but also some motion analysis and metrics as it relates to non-technical skills, for example, team coordination, team dynamics, and trying to validate some of those metrics using computer vision. So these are like the six current grants we have, different areas, different funding agencies, but all of them have in common a few topics that I would like to further explore in the next slides. So you see that our field, right, and work with like multidisciplinary teams and many collaborations, really like all these areas in addition to medicine, right? Cognitive science, psychology, social science, engineering, computer science, behavioral science, with, of course, the goal within healthcare to improve patient safety and improve the quality of patient care in different settings. And when we talk about the lab, we were really focused on also applying a lot of different technologies So you see that we're going to use like traditional methods, human factor methods, but also leveraging existing technologies to help us in terms of study design and methods, and also in development of new systems. So high fidelity simulation, right? We are at Stratus, and we really use simulation also as a research methodology for experimentations, and it has been very helpful in all our projects. I mentioned, for example, cardiac surgery. We have data collection, the real OR, but also we have a phase in the sim center, especially for usability when you're developing new tools and new systems that requires interaction between the user, could be like the clinician, and a computerized system. The sim center is really great way and facility to conduct some of these feasibility and usability studies. Wearable sensors, we use a lot of like physiological sensors to get objective markers of cognitive load, engagement, attention, and other constructs. Digital biomarkers, right? How can we measure stress and other constructs, psychological constructs, using digital biomarkers, artificial intelligence, especially computer vision, extended reality in general, all the different types of augmented reality, virtual reality, and mixed reality, and also visual analytics.